Hello. Welcome to the Ask Me Anything About Empower live webinar. We must apologize. We've had some technical difficulties with the telephone and also with the system that we use for the webinar. So we really apologize. We appreciate your being with us, and we know that your time is precious. So please accept my apologies. So let's go ahead and get started. And if you have any difficulty seeing or hearing, please send in a question using the Q&A, and we will do our best to rectify the situation. So I'm going to start out by answering some questions that we received as part of your registration for this event, and then hopefully we can get to live Q&A. Again, we've had some pretty tough time here this morning trying to get everything to work. So worst case scenario, if we can't do the live Q&A, I promise that I will answer every question and send each of you an email with answers to your questions. So no worries about that. Right? Just a couple of housekeeping notes. Again, if you have questions, use the Q&A feature to submit questions during the webinar. We'll get to as many of them as we can during the time that we have here together. And that also hinges upon my being able to share my screen with Empower. So we'll test that out in a little bit. I see a question is coming in now. All right. When we're done, you're going to get an email with a link to the recorded webinar. I've also provided a very detailed slide deck. It's a presentation that I made at one of our Inform meetings a couple of years ago. It goes into the details of how the traditional algorithm and how the Apex Track algorithm works for peak detection and integration. So I thought you would appreciate having that because it goes into a lot of the detail, the math, how things work, and why things happen the way they do. Some of that we'll probably address here during the webinar. All right? And again, any questions we don't get to, I promise to reach out to everyone individually with an email and answer your questions. So just a quick introduction for those that don't know me. I'm Neil Lander, and I've been with Waters 25 years now, which sounds like a lot, but the gentleman that hired me has been here for 52 years, so I guess it's all relative. Started out in the field doing field technical support and migrated to our corporate headquarters to work for the customer training group and spent quite a number of years there doing customer training and managing that group. And then about 5 years ago, I moved into the informatics marketing group where I look after Empower. So let's not waste any more time. Let's get right into it. The first question is a really, really good question, and it's actually two questions in one. So let me just read the question, and then I will give you my answers. So the first part to the question is, are there challenges about using MS data for quantitative methods? Second question, how do you account for the less than ideal MS peaks and integrate other than smoothing? Now I'm going to take the two questions in reverse because the first one could be quite a long discussion. So here you can see, hopefully, exactly what the person that asked the question. You can see in this case, this is some QDA data. And if I use Apex Track in this case, and I set my start and stop, and I click integrate, it optimizes the peak width and the detection threshold. Well, you can see the peak looks rather poor, and it thinks it's 3 peaks rather than 1 peak. So, of course, as the person asking the question said, other than smoothing, what can we do in this case? Because here's the same peak with smoothing. So what you could potentially do, if you didn't want to use the smoothing function for some reason, you could increase the peak width. So the peak still has that same shape as we originally saw, but if I increase the peak width, then it sees it as 1 peak, and it's integrated, it's detected as 1 peak, and I can adjust the baseline to integrate it the way I'd like. So it's a great question. And I think let's take a step back and explore this question because it is a very good question. I've seen data from optical detectors that look poor. it really does depend on the application, and it depends on the signal-to-noise ratio and the concentration and so forth and so on, because, again, I've seen chromatograms with peaks that look like this from optical detectors because they're very, very low concentration. So I think as far as the peak detection and integration goes, you can smooth, but increase the peak width. You may want to use a combination of the two to improve the peak shape so that you can do something quantitative with the peak. Now, what about the first part of the question, the challenges using MS data for quantitative methods? And that's a very good question. I think it does depend on the application. And I would say that about anything, whether it was optical detection, MS detection, whatever it happens to be, it really does depend on the application. I think what's happened over the years is with optical detection, let's just say UV detection in particular, we have come to expect nice linear calibration curves over a fairly wide range. We have come to expect percent RSDs on areas for replicate injections to be quite low, 1% or less, as the technology for HPLC has progressed from HPLC to UPLC, and as the column technology, stationary phases have improved, and we've improved our peak shapes, we are able to get quite good reproducibility on replicate injections with optical detection. Now, that being said, we also have to be aware of Beer's law, because if we over-concentrate something, then we can lose that linear relationship between concentration and response on a UV detector. And if I look at MS detection, in some applications, and I'm going to preface that, some applications, I see better sensitivity using mass detection and a wider range for the calibration curve. But in other cases, I've seen UV detection better. It all depends on the compound. And one of the things that can happen is that you can saturate the source on an MS detector, and when that happens, you lose that linear relationship. So I have seen some applications where the individual did use a quadratic fit for the calibration curve rather than a linear fit, which is what we're used to with a UV detector. So, in conclusion, it's a really great question, and it could be a whole hour's discussion just on this point alone. It really depends on the application, depends on how good your system is, meaning how clean is it. Absolutely use the highest possible quality solvents. Be very careful not to contaminate anything in the system, because if you have any column bleed or something like that with the MS detection, that adds to the background noise, and that's going to reduce your ability to see low levels of compounds. So I hope I've answered that question. And again, we could have a whole hour's discussion just on that topic. So the next question that we received, also a really great question. How is auto integration different from manual integration? Traditional integration, is it any better? So I think let's take a step back and define what do we mean by auto integration versus manual integration. Generally speaking, when we talk about auto integration, we're talking about setting up a processing method with the appropriate peak width threshold, minimum area, minimum height, whatever it happens to be, maybe some integration events, and then applying that processing method to all the samples. So I set up my processing method, I take the sample set, I process the sample set, I get a result set. That to me is auto integration. We're letting Empower use the processing method as we've created it to generate the results. And here in this slide, you see this happens to be with Apex Track. You can tell, well, because it says integration algorithm Apex Track, but also you see in the global parameters, you've got a section for detection and a section for integration. So remember with Apex Track, the detection of the peak and the integration of the peak are split into two separate functions. They're decoupled. So Empower takes the second derivative of the chromatogram, and from that second derivative, it determines what peaks are there. It detects peaks. Separately, using liftoff percentage and touchdown percentage, it draws in baselines and calculates areas and heights. So if we talk about manual integration, hopefully you can see in the slide, if you look at the integration type field, any letters that are capital letters, whether it's a capital B and a B, that means baseline to baseline, or it's a capital BV, baseline to valley, that's the result of the auto integration. If I manually move either a peak start or a peak end, you notice that the letter goes to a lower case, as you see in peak number 6 in this slide. So that indicates that I've manually, in this case, moved the peak stop for one of the peaks. So that's manual integration, where I either A, move the peak start and or peak end, or B, maybe there's a little peak in the baseline that the auto integration didn't pick up, so I draw a baseline under that peak to manually integrate it. Now, the other part of the question is apex track versus traditional. There's really no difference in this case, right? Here's the same chromatogram, only in this case I developed a traditional method. And again, you can see it says traditional in the upper right corner of the slide, but here you see the difference, the peak width and the threshold, min area, min height, and those are the global parameters you have to deal with. So the traditional algorithm couples detection and integration together, and you cannot separate those. So that's, in a very brief statement, that's the difference between the two algorithms. There's obviously a lot more. But again, if I use the traditional algorithm, I create a method, process the sample set, get a result set. To me, that's auto integration. Manual integration would be the same thing, where I've gone in and I've moved either a peak start or a peak end, or again, if I had a small peak, I could draw a baseline into a small peak that was not detected and integrated based on the auto integration. So I hope that answers that question. All right, here's another very good question. The subject of impurities, on actually taking a cue from that last question, when I look at a lot of methods, let's say I'm just doing an assay and I'm looking at an API, I usually have a big, clean, well-separated peak, and auto integration works pretty well in those cases. But then if we look at impurity methods, these become a little more challenging because now you could have a lot of very, very small peaks, and they may be fused together, and the baseline could be going up and down, and you might even have the big API peak in the middle of everything. So how do you deal with those things? So this is a great question. When we need to calculate the impurity percentage, how can choose the best integration method to integrate standards and impurity sample using the same processing method, because the amount of the standard solution is very high compared to the amount of the impurity. So when I use the same processing method, I do not have a good integration. So here is a great example, and let me just go right to this next slide. Okay, well, let's back up a second. So there's my API peak, a big peak. But when I zoom in on the baseline, now I can see I have all the impurity peaks. So this is a great example of how I can use the integration events, and that's that table underneath the global or universal parameters. There's that table underneath that I can use. So when I'm setting up my method, and I set my peak width and my detection threshold, my liftoff percentage, my touchdown percentage, my minimum area, minimum height, whatever it is I'm setting up, that may not work for all the samples. It works great for a standard, but here's a sample with lots of little peaks. So if you look in the screen capture here from Empower, what I've done here is I've used the timed events to adjust things like the peak width. And actually, that's the one I've used primarily here in this case, is to adjust the peak width at different points in the chromatogram so that I have good peak detection in a chromatogram where I've got lots of little peaks along with a great big peak. So my recommendation would be, once you've got the initial method set up, take your worst case scenario like this where you've got a lot of these little peaks, and then you can use the set peak width. You also have set detection threshold as an event. You have set liftoff percentage, set touchdown percentage. You've got all of those different events that you can work with to try to optimize your peak detection and integration parameters. So this one is also a very good question. Now, I'm going to answer this in two ways. The first thing is, because when we look at shoulders, there's a couple of things we could think about when we say shoulder peaks. Because the classic question that I've had over the years, and every once in a while I still get it today, is, I've got a small peak riding on the tail of a big peak. It may not necessarily be a shoulder, but it could be close to a shoulder. And what's the best way to integrate the two peaks? So, in this slide, in the upper left-hand corner of the slide, you see that we've got two peaks. They're not baseline separated. There's a valley point between the two of them. And if I create a new processing method, by default, this is how Empower is going to deal with it. It's going to say, okay, there's a valley point between the two, so it puts a little diamond-shaped mark between those peaks. There are different options in how we could deal with integrating these peaks. And if you look at the upper right quadrant of the slide, there we're using the valley-to-valley timed event. So the valley-to-valley timed event would draw the peak start and end to the valley point, or I should say for the first peak, it's going to draw the peak end to the valley point. And to the second peak, it's going to do the peak start at the valley point. Now, of course, there, you're going to have smaller areas under those two peaks. The lower left-hand corner, you see I've used a tangential skim. So I've tangentially skimmed the small peak off of the big peak. And there, when you use that particular event, you have a start time and a stop time, and you have something called a value. And so what Empower does in order for that tangential skim to work is it looks at the heights of the peaks at the valley point. Default value is 4, so that means if that main peak's height is at least 4 times the height of the rider at the valley, it will tangentially skim the small peak off of the big peak. You may have to adjust that value. So that's a tangential, and I know you can't see it here, but if you look in the peak table and you look at the int type, again, as we saw on the previous couple of slides, for valley to valley, for tangential skim, you would see a T for tangential. So if it's baseline, you might see baseline to tangent or tangent to tangent. It depends on the cluster of peaks you're looking at. In the lower right-hand corner of the slide, using the apex track algorithm, we have the Gaussian skim. And so this is not quite exactly the same as exponential skim in the traditional algorithm, but it's pretty close. And so you can see what Empower tries to do is it tries to skim off the rider as if the main peak was a nice Gaussian symmetrical peak. So these are some options that you have in terms of integrating peaks like this. And of course, the question that I get is, well, what's the right way to do it? And there's no answer to that. You need to decide which technique is best depending on your application, and then you have to stick with it. And just as an aside, because we're talking about integration, detection and integration, one of the things that I always stress is if you have an SOP in your laboratory, look at the SOP, because the SOP should have a picture of the chromatogram with the way the SOP says you should integrate your peaks. So before you get too deep into it, if it's an existing method, check the SOP and check how the integration is set up in the SOP. Obviously, if it's a new method, you're just developing it, that's a different story. So, in conclusion here, you can see, depending on which one I pick, the areas for these two peaks are definitely going to vary. And then when we get into Empower, I'm going to show you there is a detect shoulder event that you can use. And this would be cases, and it's only for the apex track algorithm, this would be cases where Empower can't detect the valley point, so it's going to pick it up as a shoulder. Okay? Okay. All right, great. So now let's see if we can get over to Empower. So I'm going to attempt to share my screen. So we've got some questions coming in. And so here we are with the shoulder peaks. That was the great question that we had before. So I'm going to, so here's a good case where we've got some fairly good-sized peaks. But once you get into the baseline, you can see there are lots of other little peaks in there, right? So if I go ahead and I set up some parameters, and this is actually a good time to look at that, I'm going to say let's go from, I don't know, about here, about 0.7 to about 9.5. So let's put that in. This is usually how I set up the apex track algorithm. Integrate that. So I've got lots of little peaks in here. And if we look at the int type, that's what we were talking about earlier, all of those letters that tell you how the peaks have been integrated. And if I turn on detect shoulders, and click integrate, now you'll notice that some of the int types have changed. So if I zoom in on this area, for example, see here there's a little peak. Here's a peak right here, big peak and two peaks on its tail. This peak here now has valley to shoulder. Without that event, which is the detect shoulders event, this looks like one big peak. Let me repeat that so you can see it. Bear with me for a minute. Okay. So big peak, another peak riding on the tail of the big peak, and you can see there's another peak down here. But Empower doesn't see that. That's a shoulder. That's a perfect example of a shoulder. So I'm going to right-click, add an integration event, detect shoulders. If I tick this box on, it's going to show me where the event starts. I can put a stop time in for this event. I'm just going to leave it on for the whole chromatogram, and I click integrate. So now it detects that as a shoulder, and you can see this main peak is baseline to valley. This peak is now valley to shoulder. That's the shoulder. And this peak is now shoulder to baseline. You may also see in some cases, some of these are really small peaks. You may see an R, which is a round. Like there's one there, baseline to round. Some of these are very, very small peaks. So when you turn on that detect shoulders, you'll see an S for shoulders, and you may see an R for round, depending on what the peak shape looks like. All right, so I mean that's a very small peak, and the baseline's doing all kinds of odd things there. Okay. Can you go over the ICH impurity portion? Unfortunately, that would take too long because that's a rather involved piece, and maybe that could be the subject for our next Ask Me Anything webinar. So here in the processing method on the impurity tab, this is the ICH impurity portion, just briefly, and then I can bring up an example where it's already set up. You would choose your impurity response, whatever that impurity response might be. Maybe it's the percent area against the main component, the API. You can select your main component here. You can set your reporting, identification, and qualification thresholds here. Anything that exceeds that reporting threshold will be flagged as an impurity, and you should report it. If something exceeds the identification threshold, you need to take steps to identify it. And the qualification threshold, if you exceed that, that means this is a potentially hazardous impurity, and you need to do additional testing to check the biological activity of that impurity. You can also have it calculate total impurities and say your maximum allowed value for the total, as well as have it identify a single maximum impurity. You have the ability to do impurity groups. So to do impurity groups in the component table, you choose a component type. So if I have, a bunch of impurities that are low-level impurities, when I go over to the impurity tab, then what I can do is I can group those together based on that component type. Okay? So that would allow me to give the sum total for that group. On the right-hand side, you have specified impurities. So if you didn't want to use these values here for the thresholds, because these thresholds would apply to all of the peaks. Let's say I have some toxic impurity, potentially really toxic impurity. I can set specified impurities to have specified thresholds that would apply to only those peaks. So this gives me an idea for another webinar that we could do together. Now, that being said, I do have a result set that I can show you where it's already been worked out. Just take some time to set it up. And here you can see this is already set up. And if I go to the processing method and I go over to the component tab, you see we've got some component types. And if I go to the impurity tab, I have my threshold set up, maximum allowed total, maximum impurity, and I've got one specified impurity that I'm concerned about. This list over here, this is if you're going to do an adjusted total area, you can exclude certain component types, which is actually a good thing because a mobile phase peak, a diluent peak, a system peak, those are not impurities and we would not want to include them in our calculations. And I did a webcast a while back where we were talking about impurities and talking about some of the concerns on the point of the regulatory agencies that people are hiding or potentially hiding peaks when we in fact know that they're mobile phase peaks or system peaks. And typically what do we do in that case? We use inhibit integration. Oh, I don't want to integrate my system peak or my mobile phase peak, so I'll inhibit integration in that region. Well, this is where some suspicion comes in on the part of the regulatory agencies. So if you do it this way, if you identify those peaks with these component types and then exclude them from the calculations, then you can justify what you have done. Okay, so that's a very good question. And now let me get to some other questions that I had. Hang on just one moment, because there's another one that came in. Will I get the same areas and heights for my peaks when I use traditional versus Apex track? Okay, great question. And let's clean things up here a bit, and let's go to a different project. I'm going to open this project. Now we're doing pretty well with time, so that's good. And if I take sample to review, and let's just make that look a little bit better, and let's get rid of that gray background. Okay, so here's an example. If I zoom in on the baseline here, well, it's not too bad compared to other data that I have seen. Got a bunch of peaks. Most of them aren't too bad, a couple of fused peaks here and there. If I go in, and I should have a method created here. Let's see, here's the Apex track. Well, we'll do it in reverse. Let's do the traditional. Integrate. All right, here we are. So we have our areas and heights. Now, I'm going to show you one thing here because I think it's important. One of the things that I get asked a lot is, I'm trying to set up my method and I'm struggling. Whether you're dealing with traditional or you're dealing with Apex Track, the first thing you should do, set the peak width and threshold. And I think a lot of people overlook that. And so the default values for peak width and threshold are 30 and 50, and depending on the chromatography, that may not work. So with the traditional algorithm, how do you set the peak width and threshold? Well, the first thing you do is you identify the narrowest peak of interest. Let's just say it's this one here at about 5.15 minutes. Literally draw a baseline in under the peak and click the Set Peak Width tool. And so it sets the peak width, in this case, to 7.5. How do I set the threshold? Well, what you should do there is zoom in on a portion of representative baseline. You don't want to set it on an area where you've got peaks. Otherwise, you're going to get a very high threshold, and then your peak detection won't work. Okay? So once I've got that done, and I'm also going to add in, because I don't want to look at stuff outside of this region, let's put an inhibit in here, I don't know, till about 4.8. How about that? And then what we'll do is we'll put another inhibit on the back end of this chromatogram so that we can just look at peaks of interest. And now I'll click Integrate. Okay? So the traditional algorithm is easy to work with, provided that you set the peak width and the threshold up front. Then you can add in your integration events as needed. And if you say to me, well, the run is too long and the peak width and the threshold don't work properly throughout the run, well, then you can always right-click, add an event, and you've got all kinds of events that you can pick from. So you have a set peak width. You have set liftoff. You have set touchdown. You have set minimum area, set minimum height. So you can always fine-tune it by using these events. Just as note, any event that begins with the word set as a start time doesn't have a stop time, grayed out, which means here I've got a global peak width of 7.5. If I set my peak width, that's not the one I wanted, that one, okay? If I set my peak width at 6.5 minutes into the chromatogram and I set it to some other value, that new value is now in effect for the rest of the chromatogram. So I might have to put in a second event, reset it, or set it to a different peak width, depending on what my peaks actually look like. Right? So it's as easy as that. If I'm going to do an Apex Track method, let's do that. How do I set that up? Right? I'm going to do Apex Track. With Apex Track, I determine over what portion of the chromatogram I'd like to have peak detection. So, 4.8 to 13.4. And then what I do is I let Empower tell me when I click Integrate what's the optimum peak width and detection threshold for the chromatogram. So it looks at the second derivative of the chromatogram and it sets the peak width based on the tallest peak in the second derivative, and it also sets the detection threshold based on the peak-to-peak noise in the chromatogram. So again, setting these up front, not difficult to do, and if I need to optimize it, I can optimize it somewhere during the chromatogram with the events. Now, let's get back to the person's question. If I wanted to make a comparison of using traditional and Apex Track, okay? And while I'm opening up the report publisher, I'll give you the answer now. You will see differences in the areas and the heights because they are two different algorithms. So there's no surprise, okay? There's no surprise. So what I'm going to do is I'm not going to make a fancy report here. I'm just going to show you very quickly. Where's my processing method? Is okay. Now let's try to zoom in. So you can see for the first peak, you can see the areas are a little bit different. The heights are a little bit different because, again, they're two different algorithms. And so it should not be a surprise that there are differences. Now, some of these you see a little bit more of a difference than others, depending on what the peaks look like. Some of the peaks in the chromatogram are small and they're fused and so forth and so on. So yes, because of the fact that the algorithms are a little bit different, you're going to see differences in the areas and heights. Is this a point for concern? No, because if I run my standards and I generate a calibration curve, and I run my samples and I perform quantitative analysis, it should not affect my quantitative results. Here's another very good question. Where can I get more detailed information on integration events? So, great question. And the answer there is go to the help. The help has a lot of good information about integration events. Now, I've bookmarked the tangential skim. Now, let's just open this window up so we can see the information. For each of the different events that you find in your processing method, whether you're using the traditional algorithm or you are using the Apex Track algorithm, it doesn't matter. Type in the event and you'll get something like this. You'll get an explanation with a picture. And the reason I'm showing a tangential skim is we talked about it before. Tangential event has a start time, has a stop time, and it has a value. And that value, get down to the nice picture here in the help, is it looks at the heights of the two peaks at the valley point. And it says the height of the main peak is greater than or equal to the height of the rider peak times the value, then it will employ the tangential skim. 4 is the default value. You can change that. There's different types of skim. This is called a classic rear skim, as you saw in my slide earlier. But what if I wanted to skim the big peak off of the little peak? All right? So what we would do is we would change the value. You see, for the classic skim, the value is greater than or equal to 1. For the non-classic rear skim, it's going to be somewhere between 0 and 1. If I want to skim the small peak off of the front of the back peak, I can put in a negative value. So this is why I say the online help is terrific for these different things. If you have any event, search for it. Here, let's take a different one. Okay? Allow negative peaks. List topics. All right, here it is. Display it. Lots of stuff to read, but of course, what's really helpful are the pictures. Because you can see, in this particular case, maybe I've got a refractive index detector, and I've got positive and negative peaks in one chromatogram. Okay, so if I turn on the allow negative peaks, that would allow me to integrate the negative peaks. All right, so please go to the online help, and there's lots of good information on these timed events. Okay, here's another very good question. Sometimes I have to do manual integration on peaks in sample chromatograms. How do I get Empower to keep the manual integration when I reprocess? If I reprocess, Empower uses the original integration parameters. So, great question. And I'm going to first give you the explanation, and I can show you here. We have some time left. Right? So if I have my sample set and I process that sample set and I get a result set, and let's just take this result set here. That's a blank, so it doesn't look very nice, but you know, there's a standard. So, okay, we have peaks. Great. So let's say I come to a sample, and in a particular sample, I'm not happy about some integration. Now, these are actually pretty good peaks. That's obviously a subjective statement. But let's say I'm not happy with something in the integration in one of these chromatograms. And then I decide, okay, I'm going to go in and I'm going to manually reintegrate the peak. Okay? Let's say I don't like that peak. Okay. So I just did a manual integration on that peak. Remember, the int type reflects the fact with the lowercase letter that I've manually integrated that peak. So what you have to do in this case is go to File, Save, Result. Okay? You exit out. You right-click on the result set, Process, and you're going to use, in this case, I'm going to use the processing method. I think it's this one. And you want to click Use Existing Integration. Right? Now, we're not going to recalibrate. We're just going to requantitate those samples. You could calibrate and quantitate. And now what it's going to do is it's going to use that manual integration it's processing the sample set. If you go out and you reprocess with, go back to the sample set and you say reprocess, guess what it's going to do? It's going to use the original processing method, and you won't get the result with the manually integrated peak. Okay? So now, if I go to review, there's today's sure this is wait here for this to open up. I don't remember which one I did it on, but look, I have a feeling I used the wrong method, so I apologize there. This is 3D data. That's probably why that happened. All right. So what you have to do again is, once I've reviewed, see on a 2D set, let's just use that. Running down on time here, so I got to watch out. All right. Okay. So again, if I do something like this, for whatever reason I'm not happy, right? I save that result, close it. Well, let's just see what processing method we used here in this case. It's called Inform PM. Fine. So I right-click, process, use existing integration, quantitate only. It's going to go off, and it's going to use that manual integration. All right? So if I look, there it is. Now it's used the manual integration. So the key is, make sure that once you do the manual integration, go up, say File, Save Chromatogram, Save Result, back out, right-click on the result set, Process, use existing integration. And that'll use any of the manual integration that you may have employed when you first was working with this particular thing. And I think I realize now, maybe, if I can't find it, so be it. I don't remember which one I did here. Ah, there it is. It did work. All right, good. So we're getting down on time here, and I've got to watch it. Any questions that we didn't get to, I will make sure that I answer in an email to you. So, sorry for the delay again, and sorry for the running out of time here with getting to all the questions. Remember to check out my blog at waters.com/empowertips. You can subscribe. The advantage to the subscription is you get an email every week with the entire tip, so you don't need to go back to this URL. And the Waters Knowledge Base, if you haven't looked at the Waters Knowledge Base, I encourage you to do so at support.waters.com, because the nice thing there is we've got somebody that's moving all of the tips into that knowledge base, and you can actually search on a topic. So you can search on, like I did a whole series on dealing with QDA data with Empower. You can search on that, and then you can drill down into the informatics area and into my Empower tips, and you'll find all the tips that are related to working with QDA mass data and Empower. Somebody just emailed me about that the other day, and so it's a good point to make. Check out that knowledge base. All right? So we're going to accumulate any of the questions that we didn't get to, and I know there were several we did not get to. I apologize, and I think we're just about out of time. So thank you very much for your attention.